Hello, and welcome to this presentation of the ongoing ETSI NFV proof of concept named Active Video Monitoring in an Orchestrated Layer 3 VPN. This intermediate demonstration provides a sneak preview of the full demonstration to be held later this year in October in Düsseldorf. Today, the PoC team is represented by me, Mats Nordlund from Netrounds, together with my colleague Marcus Freeman, and Stefan Wallin from Cisco. The presentation is divided in three parts. First, we will clarify the PoC goal and describe how it relates to the ongoing work in ETSI. Then there will be two demo sessions, one related to the orchestration and the other focusing on active tests and monitoring. So Stefan, why don't you start explaining what the PoC goals are?
So, what is the goal of this PoC? One of the primary goals is to illustrate the value of tight coupling of fulfillment and assurance. Classically, fulfillment has been one stovepipe and assurance been another stovepipe, and we try to bind them together as an afterthought with out-of-date inventory systems, etc. In a dynamic world with services coming and going, it's very important that the orchestrator takes an active role, not only just orchestrating the configuration of the service, but also orchestrating the assurance as part of that. That gives a lot of benefits since the orchestrator knows where the services are. The orchestrator can drop virtual probes. It can make the assurance system service aware because we know which services are running. Talking about service assurance, classical approaches tries to collect massive amount of device-oriented data and try to infer the more service-oriented KPIs based on that. That has over 20-30 years sort of proven not feasible. One of the theses we're trying to illustrate here is that we need to do KPIs for the services. We need to do active tests of that. So for a specific service, what are the relevant end user KPIs? And let's do active tests of those KPIs rather than trying to infer them. And how can we avoid this being a huge software project? We need to find an agile way of doing orchestration, fulfillment and assurance. And what we're showing here by using Yang data model is that we can have a model-driven orchestrator, and the Yang model is not just describing the config aspect but also the assurance aspect. So whenever you change your Yang data model, you change how the orchestrator behaves. I will now hand over to Mats to describe more of the topology and use case we're using here.
Okay, let's start with a high-level view of the use case and the underlying topology. End users are connected through radio access networks, through an interconnecting VPN to reach video content and other internet services. The PoC uses three different VNFs, a virtual router or a VPE, as well as virtual test agents and a virtual cache. The virtual router is launched close to or actually at the main data center location, whereas the virtual test agents are launched on multiple locations throughout the video delivery network. Virtual cache or virtual caching features are located as close to the customers as possible to improve performance. There are three different locations where these VNFs will be launched. First, the main data center location, and secondly, the RAN gateways between the VPN and the radio access part, as well as the backhaul demarcation close to the eNode Bs or the access devices. So if we zoom in to the details, we will see the three different NFV PoPs, the main data center, the RAN gateway, and the NFV demarcation point. At the main data center location, here is the virtual PE, interconnecting the content network and the internet services, as well as building the VPN towards the RAN gateways. At the different NFV PoPs, VTAs or virtual probes will be launched in order to initiate active tests and monitoring. The virtual cache will also be launched at the NFV demarcation point, but that is not really finished or finalized at this point in the PoC, so that will be something to add until the final presentation later in October. The service orchestrator is responsible to configure the various network devices, such as the VPE and the physical CEs, whereas the NFV orchestrator is responsible to launch the VNFs that are used in this POC. The service orchestrator will also interact with the test controller to trigger activation tests as part of the fulfillment phase, as well as initiation of the active monitoring that is part of the assurance. Even if this is a specific scenario, this topology can be generalized to include multiple radio access networks as well. In the ongoing work at ETSI, these VTAs, virtual test agents, located here in the center part of this illustration, is one of 3 new components that are proposed as extensions to the ETSI NFV architecture, and this is work that is ongoing now in the REL work group. So in addition to the VTA, there is also a test controller as well as the test results analysis module. And this proof of concept, or the ongoing work that our PoC team is now performing, is the first of its kind to showcase the interaction of these 3 components together with the OSS and the NFVO. So Stefan, could you please help the viewers understand how the different POC members map into the reference architecture?
So let's briefly look at the moving parts of this POC. On the top we have Cisco Network Services Orchestrator enabled by TailF. It acts as the NFV orchestrator, managing the mono orchestration of the VNFs, and very important, also acts as the OSS fulfillment part, doing the end-to-end service orchestration on top of the running VNFs after they've been up and running. The VNFs, we have the Netrounds virtual probe, the virtual test agent, and the CSR virtual PE router. All the VNFs running in OpenStack. We also have a sort of a distributed NFV PoP at the demarcation point using the Telco Systems Cloud Metro node on Intel hardware, where we can drop virtual probes on the compute node in this space. Acting as the test controller and test analysis module, we have the Netrounds control center, which at runtime collects the relevant data from the deployed virtual probes, aggregates that into SLAs. All of this is bound together with Yang data model. So in NSO, the descriptors as well as the end-to-end services model in Yang, the SLAs, etc. are modeled in Yang, and that is configured in the test controller to monitor those. So these are the moving parts. Enough PowerPoint. Let's move on to demo time. So I will now show the first orchestration part of this demo. The steps the orchestrator will go through is we will set up the VPN between the RUN gateway and the main data center. So the first thing the orchestrator needs to do is to start the virtual PE router in the main data center. So NSO will ask OpenStack to start the virtual PE. Once that is done, NSO will continue to set up the network connectivity between the virtual PE and the CE, picking the IP address and VLANs from the built-in resource manager. Once that is done, the orchestrator will continue with the VPN service activation. So while the first thing here was more focused on mono, using descriptors to start virtual PEs, the second part is more related to the OSS part, namely setting up the VPN, doing the runtime configuration of the PEs and the CEs. But very important, it's not just the config part of the routers, it's also setting up the actual SLA that we would like the VPN to adhere to. After configuration of the SLA, the orchestrator will continue to configure and drop virtual probes. So the orchestrator will deploy a virtual probe in the main data center in OpenStack. It will deploy probes in the RUN gateway, and very interesting also at the demarcation point, since we have a compute node in the demarcation point. So finally it's 3 instances of virtual probes that will be deployed. But it's not just a naive VPN provisioning case. We need to make sure that the VPN is working. So the NSO will also trigger an activation test before considering the VPN working fine. That includes talking to the Netrounds control center to configure according to the defined SLA, request the control center to measure service level specification by utilizing the traffic from the virtual probes. And after my demo, Marcus will show these steps. Once all of that is done, we can consider the service operational because the activation test passed. So at that point, the orchestrator, with the assistance of the Netrounds control center, can do continuous service level specification monitoring and tracking to detect any violations. So in this demo, I will show the first steps here before handing over to Marcus. So Cisco NSO acts as the orchestrator. NSO is the rebranding of the TailF NCS product. So while it says NCS, that's the Cisco NSO orchestrator. So here we have the physical CE at the RAN gateway. I will start by creating a VPN. For the video delivery. And here we have the network service descriptor for the virtual PE, so I can pick a relevant NSD, the deployment template that will then turn up as the flavor in OpenStack. Can then just drag this physical endpoint here, call that the RAN gateway. So these are then the parameters for that endpoint. So at this point, NSO will continuously iterate over all the steps I showed on the previous slide here. We can dry run the first step. So what needs to happen first is to start a virtual PE in OpenStack, and here we see the representation of the network service descriptor that will turn up then as a tenant in OpenStack. Let's start that process. What we can see here to the right now is that we can see that we are waiting for the virtual PE to start. Here's the request to have it started. Here we got a VM message back, so we have the virtual PE up and running. In a real scenario here, NSO would just continue, but in order to show you the steps, I will sort of stop at every step here. We can now put the virtual PE there in the data center. So this was the first iteration in the process where NSO iterates towards the final convergence. So NSO has a principle of state convergence to the final state. So this was step number one. Let's ask NSO to continue to stop the CEP connectivity. And to have NSO to progress to the final state is a continuous redeploy request. So redeploy tries to reach the next step in the process. What we can see here is that NSO picks the IP addresses and the VLAN IDs in order to set up the connectivity. So we have the connectivity now from the CE to the PE. NSO continues now with deploying the virtual test agents in the main data center, in the RAN gateway, and in the demarcation points. Based on the SLA, it also requests Netrounds control center to start monitoring that after a successful activation test. The activation test is important. Don't consider this VPN up and running until we verify that it's actually running. So, as I mentioned, the final steps of the orchestration process is related to assurance, and a fundamental step here is to define the SLA. So the NSO configuration steps configures the SLA and delegates to the Netrounds control center to monitor it. Let's look at the configuration of the VPN SLA itself. So you can define any number of service levels. We have one called Video Gold, and for that SLA you define thresholds for the network KPIs. Based on those KPIs you can define what's considered a good state, what's considered an acceptable state. This configuration is then sent to the control center for actual monitoring. So I hand over to Marcus now, who will show you all these steps, how that works in Netrounds control center.
The orchestrator has instructed the VNF manager to deploy the virtual router, this one. It has configured the layer 3 VPN, the video delivery VPN, this part, and it has now also instructed the VNF manager to deploy the virtual test agents that will be used to verify and assure that the end-to-end network connection is working as it should, but they will also assure that the service is reachable and that the service is working from an end user perspective. So I will now move into OpenStack and show the probes coming online in OpenStack and become active. We will see when an activation test is started, and we will also see that the orchestrator starts monitoring the service and the network service level specifications. Here we are in OpenStack. We had the video delivery VPN CSR 0, the router you can see here, and the virtual test agents are now being deployed. Okay, so here we can see the main DC, the RAN gateway NFV PoC has a virtual test agent deployed, and the RAN demarcation point as well. And what will happen now is that these three the virtual test agents will connect to the test controller. So I will now move into the test controller GUI, and in any second now the virtual test agents, the virtual probes, will connect to the test controller and come online in this portal, so we can see everything happening live here. And once they are online, they will the orchestrator will automatically trigger the activation tests. So I will just reload this page and let's see if we have some probes online here. Okay, so here we have the RAN gateway that has now an IP address on the 10.100 network. Let's see if we reload again here. The main DC is coming online. So these three probes, yeah, now we can see all of them are online. The last one will get an IP address as well, and then the activation test will start running. First an activation test of the network connection, and then an activation test verifying the service end-to-end. So we'll move into the dashboard here. Here we are at the dashboard of the test controller, and you can see here that the layer 3 VPN test video delivery, the network test is done, and the user experience or the service validation test is ongoing. So I can just briefly go in here, and what is run here is some simple tests for this proof of concept. So two of them are basically UDP tests verifying the delay and jitter and loss, and two of them are real stateful TCP tests to verify that the performance is good enough. I will not go into the details of this at this webinar, but to mention that the test sequences that can be run that you can use are extensive. Complete carrier Ethernet type of test with layer 2 control protocols, and what is also really interesting here and important is to verify the service. So in this case it's the service verification here for video delivery is basically to test the internet connection by doing HTTP requests and some DNS validation, but also real over-the-top monitoring to see that the over-the-top video is working, and it's requesting from a real content distribution network, in this case Akamai, and one of them is delayed to see if the caching, once you start something delayed, if that will affect the result. I will not go into the details of that now, just to see that both of these tests are okay. So if both of them are okay, what will happen? Yeah, now it's okay. The orchestrator will now start monitoring both the service and the network. So it will trigger SLS monitoring of the service and network perspective. And as Stefan mentioned earlier, this is now part of the Yang data model, so it also includes assurance. So the vProbes will start collecting statistics, and these statistics can be fetched from the orchestrator, and the orchestrator can be in control that everything is working as it should. And if there would be a problem, you can of course trigger alarms, and you can also even trigger troubleshooting tests. So you can talk to the test controller to trigger troubleshooting if the SLS would be outside the boundaries of what is okay. So I will just see here before I end that the measurement results starts coming in, and that we get, it's a green SLA icon. We get some results here. Everything looks fine, everything from the activation test to the monitoring, and from here on I now leave back to Stefan to show how this looks in the orchestrator.
So Marcus just showed you how the virtual probes were started, the main data center, the run gateway and the demarcation point, how the control center did an activation test to make sure that the service was up and running okay before we considered it done and leaving it to the assurance state. Once the activation test was happy, the Netrounds control center started continuous monitoring of the VPN service. So now we have a constant monitoring end-to-end of the VPN. So you could see part of that in the web UI of Netrounds control center. I will just briefly show you how the orchestrator can fetch those values from the control center. So I have my VPN up and running here. I can navigate down to the video delivery, check the service levels. So I have a video gold service level with a current state of gold. So this is fetched at real time from the Netrounds control center. Any violation there would change the state. I can also, on the complete VPN, utilize the test capabilities of the control center. So I can do an in-service test to make sure that everything is working fine if I need to investigate anything. I can also go down into an individual endpoint, since we have a probe at the endpoint, so the run gateway endpoint. This position in the topology. I can run speed tests to monitor the actual speed. I can run troubleshooting tests utilizing the capabilities of the control center. I can also check KPIs at runtime. So here we see the basic network KPIs for various intervals, the values and the availability. So this again is fetched in real time from the control center. So that concludes this demo part. So what have we tried to illustrate in this early video of this POC, and what will be demonstrated going forward with the full implementation? Looking at MEF's vision for the third network, service orchestration need to be agile, and services need also to be assured. So by having a data model driven orchestrator, we can be agile, and the orchestrator need to orchestrate both fulfillment and assurance. Talking about assurance, how can we truly understand the end user quality experience of a service? Passive monitoring is not an option. Classical approach is trying to collect device data and infer the service quality has also proven not feasible. So active tests that measures the true KPIs for an end user need to be part of an orchestration solution. And we need a common Yang data model that enables tight coupling of fulfillment and assurance. One data model that is concrete, covers the fulfillment and assurance aspects. And also equally important, a data model for the mono stack and for the OSS stack. So we have the VNF descriptors, we have the service models, all in one Yang data model, makes the integration very complete and straightforward. So thank you for listening and looking forward to meeting you. Thank you, bye.